First of all, I'd like to thank Mr. Ram and Mr. Sashi Kumar for having given me this invitation, and looking back at the other eminent people who have delivered this lecture. I consider it a great honor and a privilege. And having read about Professor Pinkham a little bit, I think the values that he stood for and the importance that he placed to honesty in reporting, honesty in everything that one does in life, and standing up for one's beliefs and standing up for the right causes, I think is very, very inspiring. And I hope that all of us can, be able to stick with those principles in our life. I think it's, as both Sashi and Ram said, journalism is at a crossroads right now. There's quite a test in terms of many of the media outlets, not being able to continue with their regular activities. I know a lot of reporters have lost jobs. Probably the print media has particularly suffered. But on the other hand, the online and digital content has gone up tremendously, many, many fold. And I would like to say something a little later on about my own experience with journalists over the last 6 months. And it's been, on the whole, extremely positive. Particularly the serious science journalists who've been covering this pandemic. I've been tremendously impressed with the breadth and depth of knowledge these journalists have, with the amount of homework that they do really to understand the issues, and the kind of questions that some of them have asked me. Sometimes I'm, struggling for answers. I have to actually go back and look up information or read or talk to someone else. So it has really given me a lot of respect for journalists who've been trying to cover this pandemic from all over the world. And the kind of stories that have been coming out, I think, have been tremendous and, have played a huge role, I think, in shaping public opinion and in shaping also people's behavior. And that's something I want to come back to, because behavior, individual behavior, and of course the behavior of communities as well as of governments is what is going to make a big difference in the way in this pandemic unfolds. But perhaps I can start off by giving a little bit of the timelines over the last 6 months, the history. I mean, it seems such a long time now, but it's only been 6 months. Most people were on their Christmas, New Year break at the time that this outbreak of atypical pneumonias was happening in Wuhan. And on the 31st of December, our office in China actually alerted the headquarters about reports in the Chinese media about these atypical pneumonia cases. And the Chinese government confirmed that right away. And so on the 1st of January, actually, we activated what's called the Emergency Operations Center. The WHO is actually an organization that was set up by and serves the 194 member states. So the WHO is not an independent body that does its own thing, but we consider ourselves a secretariat which serves the needs and the wishes and the demands of the 194 member states, which come together every year at the World Health Assembly, but they also elect a smaller number of about 25 to 30 countries that serve as the executive board. And the executive board and the World Health Assembly are the governance mechanisms. Everything that WHO does has to go through and be approved by these bodies. And they are the ones who make the rules and who set the standards and the boundaries about how WHO can operate. Now, of course, the main function of WHO, when it was set up in 1948, was to be the global health agency. Now, of course, things have changed a lot in 72 years. At that time, probably it was the only global health agency. Now we have many more. But it still retains a very unique position because it is the only normative standard setting health agency globally. And that function is something that has been recognized by everyone as one of the critical functions of WHO. It's not just in the medical or clinical area, but the public health space, but also setting standards for things which are linked to health, the determinants of health, like air quality standards, for example, water quality standards, road safety, nutrition, all the environmental, social, economic determinants of health, and tobacco is a big one as well. Now, in all its years, the WHO has only been able to come up, or the member states have only been able to come together to come up with 2 binding regulations. The first one is the International Health Regulations, which were last updated in 2005, which is very relevant for this pandemic. And the other one is a Framework Convention on Tobacco Control. These are the 2 which have some legally binding clauses, and which countries actually do have to adhere to and do have to report on. And there's a mechanism, again, agreed between all the member states on how they do that. Now, the International Health Regulations actually is the one that deals with how countries will prevent, detect, respond to outbreaks and emergencies, how they report data to WHO, and how this data is then used, disseminated, made publicly available, and then the response based on that. So this is what gets activated as soon as there is an outbreak reported by any country, anywhere. It doesn't matter if it is plague, or if it is polio, or if it is, there are a number of diseases that are considered reportable diseases within the International Health Regulations. So if any of those diseases are observed in a country, they are supposed to report it. And you have national focal points. So the national focal points, they all form a network. And they were brought together on the 4th of January to be informed about this outbreak of viral pneumonia. And what really happened was things moved quite fast. And on the 11th of January, we had the genetic sequence of this virus, of the first 6 virus isolates from China. I think they were all from Wuhan at that point, which were very quickly deposited in a public database by the Chinese authorities. So we had, on the 12th of January, the world knew that this was a new coronavirus, and we had the whole genetic sequence. Why is that important? Because if you know that, that's the only way that you then move to the response, that is diagnostics. Because without diagnostics, you cannot obviously detect and diagnose any disease. And so based on the sequence data, scientists around the world were quickly, within 24 to 48 hours, developing the diagnostic test that would be needed to detect this. And that is how we were able to prepare a large number of countries by making those SOPs available, by shipping the reagents to countries which did not have them, and by equipping labs, making sure that the labs around the world which deal with these kind of viral diagnostics, mostly the influenza lab, we have a big influenza lab network globally, which has a lot of capacity to look at viral infections, and national labs and so on. So within 48 hours, we had the diagnostics in place, which was, I think, a huge plus, which has never happened before, I think, in any other outbreak, epidemic. And the other thing that happened because of this was that scientists also started working on vaccines very early on. So if you look at the speed with which the vaccines have been developed, it was only possible because the sequence data was available and that it could be immediately used, because a lot of the viral vaccines now are platform based, and all you need is to plug in the specific sequence of a new pathogen. And that is why we see today over 200 vaccine candidates in development and over 27 of them now in clinical trials. I mean, it's an unprecedented speed at which things have happened this time around. And it's been amazing to be in the center of it and to watch the science unfold. Now, one of the important issues and questions was obviously about whether this virus was likely to become a pandemic, was it likely to spread around the world, and what sort of impact would it have? Now, at the beginning, it's really very hard to predict what's going to happen. We've had experiences with coronaviruses in the past, of course, this is not the first coronavirus. So there are previously 6 known coronaviruses. 4 of them cause a common cold that all of us have suffered from and are not very serious. But 2 of them, the SARS-CoV-1, which caused the SARS outbreak in 2003-4, and the MERS, the Middle Eastern Respiratory Syndrome coronavirus, which was first detected 2011-12, obviously in the Middle East, but has caused outbreaks around the world. Now, the SARS-1 actually was controlled within 8 months, and it killed about 800 people at that time around the world. Of course, it caused a huge scare, particularly for global travel and so on. It did go to many countries out of China, starting from China, Hong Kong, and went all the way to Canada and so on. But it hasn't come back. It was, and it's important because the properties of the virus are different, even though this one is a close cousin of the SARS one. The MERS, on the other hand, is a virus that is in the animal that carries the virus is a camel. And the camels can carry the virus without being sick, and they then pass it on to human beings. And so from time to time, you get outbreaks. And it also causes human to human if you're in very close contact with the patient. So we knew a little bit about previous coronaviruses to make some educated guesses about how this would behave. But the properties of this virus turned out to be quite different in terms of the transmissibility, the ease with which it spreads from person to person, and the speed at which it's been able to move around the world. Now, we warned of human-to-human transmission around the middle of January, and it was confirmed a little later by reports coming out of China. We also convened the International Health Regulations has an emergency committee that discusses any of these kinds of global emergencies. And they got together on the 22nd of January and came back with a decision that it wasn't yet a public health emergency of international concern. Again, WHO, the way it operates is it relies on expert advisory groups from around the world to advise whether it's norms and standards and guidelines, or whether it's things like this, where you have to take decisions. They're all informed by top-level scientific experts that form these committees. So the emergency committee at that time said it wasn't yet a public health emergency of international concern, but the Director General reconvened them a week later on the 30th of January. At that time, there were 82 cases outside China. The first case had just been detected in Kerala on that day, and there had been no deaths outside of China. At that time, the emergency committee said, yes, this is can constitute a public health emergency of international concern, which is the highest level of alert that the WHO can actually give to the world. It basically tells the world, get ready. This could be a very, very serious thing. It's not declared, very easily. The public health emergency of international concern, the last one, of course, was Ebola in the DRC, and previously it was a Zika outbreak in 2016. Once that happened, countries are expected to really up their preparation for being able to deal with this infection as and when it entered. Through February, we continued to work. In fact, we brought together global scientists for a forum, a research forum in mid-February, because we realized that the solution or the way out of this pandemic is going to be through science, and that we needed to really convene the scientists to get their views and opinions. And I think this has again been a change from previous, and we've learned, of course, every time you learn and you improve. And after 2014-15 Ebola in West Africa, WHO was criticized quite a lot. And so there was a big overhaul of the emergency program undertaken at that time. And one of the things that emerged from it was the need to be prepared not only for a public health response on the ground in terms of surveillance and being able to put people on the ground and do all the steps that are needed, but also in terms of the research and development that would be needed for a new disease, or for a disease which exists but for which the world has neglected, the development of tools. And we know this is true. We have been living with diseases like tuberculosis and malaria for millennia. We've also been living with a lot of other diseases which are called neglected diseases, neglected tropical diseases, which affect mostly people in the poorer parts of the world. And we have other diseases which are very serious, but which are rare. Things like Nipah, like Ebola, like other hemorrhagic fevers that occur from time to time that kill people, but do not constitute enough of a, let's say, numbers-wise, enough of a threat to the world for the world to invest in research and development. So the WHO actually highlighted this through what we call the R&D blueprint, where we listed many of these infections, mostly viral infections, by the way, and mostly infections that come from animals, so zoonotic infections, saying that anytime we could always have a global outbreak with any of these diseases for which the tools don't exist. And on that list was something called pathogen X, which could cause disease X. And what that really meant, and what the experts who developed that list meant, was that in the future, there is going to be an outbreak with an unknown pathogen for which we will not know anything when it strikes us. What can we do to prepare ourselves in terms of being ready with the kind of labs that you might need to work on this, and training scientists and having the capacity to quickly put together diagnostics? And then how do you develop treatments and vaccines for an infection? So luckily that groundwork had been done, that platform existed. And so we activated this blueprint and we brought together 400 scientists in middle of February. At that time, travel was still possible. So people actually physically came to Geneva. Of course, many people connected virtually as well. And we shared experiences. The Chinese scientists that could not travel, they connected virtually. At that time, they were the ones who were seeing firsthand this disease. Rest of the world hadn't seen much of it. And so they described both the clinical as well as the epidemiological features. We learned a lot from them in the early days. And then we went on to develop a research roadmap, which laid out what scientists need to work on over the coming months, starting from epidemiology and transmission and the animal source of the virus, going all the way through clinical management, infection prevention and control, diagnostics, vaccines, therapeutics, but also very importantly, social science and ethics were two working groups that were set up, because right from the beginning, we understood that ethics in everything that we do is going to be important. And we needed bioethicists from around the world to be watching and advising on this, and also social and behavioral scientists, because no public health campaign works actually without understanding how public responds to things that are happening around them and how behavior change can be brought about. And in fact, very recently, we've set up a behavioral insights unit based on some of the work that's been done by behavioral economists and things like the nudge factor and so on. So these are some of the newer things that we're putting in place, which we had started thinking about before this pandemic, but we had to accelerate the speed at which we were doing this. And as a head of the science division, I'm in charge of making many of these changes in the way in which we operate, in the way in which we do our norms and standards and guidelines, and in the way in which we communicate. So starting from there, of course, now we've learned more about the virus, how it transmits particularly has been of importance, but it's a very different kind of virus. And so I don't know if how many of you actually remember a very enigmatic statement that was made by Donald Rumsfeld, who was a Secretary of Defense under President George Bush, who said that there are known knowns, there are things that we know, there are known unknowns, those are the things that we know we don't yet know, but there are also unknown unknowns. And I think this statement well describes the reaction to the COVID-19 pandemic, and particularly the role that the media has had to play in this outbreak. There's a lot that we still don't know. Huh? There is, of course, so much that we've learned, but it's what we don't know that still worries us. And that is why we continue to convene scientists and make clear the knowledge gaps that still exist. So information and misinformation spread as fast as the virus did. This was one of the early challenges that we had. There were rumors and conspiracy theories. The virus also became politicized. There was mistrust among countries. There was a lot of anti-intellectualism, anti-science views, distrust of expertise. All of these was increasing the uncertainty. And this is really the time when you actually need science journalists more than ever. There was a tsunami actually of information and something that we called the infodemic. This was a term that was coined quite early on in WHO to go alongside the epidemic. We said there's also an infodemic. There's a huge amount of information going out there, a significant amount of which is actually misinformation, either willful, planting rumors and lies and so on, or people just, not applying their mind and just putting out things over there. The other trend which happened a lot in the field of scientific publishing was that the good thing was that most of the journals actually removed their paywalls for anything related to COVID-19. So they made the everything accessible, freely accessible, even those journals which normally have a very high subscription fee. And this was done very early on, and it was something that we had earlier discussed with journal editors, but we were very appreciative of that. The other thing that happened, of course, was that there are these preprint archives. You have the Med Archive and the Bio Archive. These preprint archives started a few years ago by the scientific community, which wanted to share information ahead of publishing. So if you've written a paper and you put it out into this preprint archive, then what happens is that you get a peer review from scientists around the world, which is an informal peer review, and sometimes get very good feedback. And it's a way of also making the scientist or the author themselves think about their paper or improve it before they submit it for a formal peer review to a journal. So the amount of preprints just increased tremendously. I think I've got some numbers. But what that did was that the media journalists also had access to preprints. Okay, preprints are normally meant to be looked at by the scientific community, and particularly those who are already experts in that field, because they can judge whether or not a paper has some huge errors in it, and whether you can actually trust the methodology if things are looking like they've been done well, documented well, and then you go on to reading the results. But first you look at methodology always. So that's what a scientist does when they read a scientific paper. But when the lay public and the media is also looking at this, they're not necessarily applying that same lens. And so what was happening is a lot of things which had just been put into a archive as a preprint were then picked up and became headlines, around the world. And there was no distinction between things which are still not vetted and considered to be scientific facts and things which are unverified observations that have been just put up by someone. And you have, it's a difficult task to actually distinguish between high quality and poor quality in the preprint literature. So we again started quite early on looking at this and saying, okay, what can WHO do to provide the right information to people? And so we were screening both the published literature and preprints every day and making it available to people, and also putting out some highlights from that. But it's a very difficult task for a small team of people who have many other things also that they have to do. So So that is where, again, I think journalists also need probably that insight, and a scientific training, I suppose, helps if you're a science journalist in being able to distinguish the good quality and the bad quality. You also need, when you're reporting on a pandemic, it requires both nuance and context. And again, in the beginning, there was very little context, because what we had seen was the China experience of the complete lockdown and the way in which, of course, they handled it extremely effectively. And at that time, I think many people believed that this kind of response would not be possible in other countries. But then we went on to see many other countries actually also implementing lockdowns in an effort to control the spread of this infection, because basically this virus spreads through person-to-person contact. It's a respiratory virus. It comes out when you're coughing, singing, talking loudly, breathing even. And if you're in close contact with somebody who's got the virus, then it can, you have to be in prolonged close contact with that person. You can actually get infected. So one of the things about this virus which makes it very difficult, or a couple of things about it. One is that even people who don't have many symptoms, or minimal symptoms, or even no symptoms, can spread the infection if they are carrying the virus. So what we call asymptomatic people. Then you have a group called pre-symptomatic. That is, I'm infected, I'm carrying the virus in my respiratory tract, but I don't have any symptoms today, but a couple of days from now, I might develop symptoms, but I'm actually infectious today. So today, I don't know I'm sick. I'm going around meeting people without taking much precautions, actually spreading the infection. So epidemiological studies have shown that the secondary infections occur in about 10 to 15% of household. So the most common is within the household is when people get infected. And that's why the Chinese very early on started moving family members out into separate quarantine facilities, because they found most of the transmission was occurring within households. And then it's so 10 to 15% and somewhere around 2 to 5% to non-household contacts, so more casual contacts. We've also seen what we call the super spreader events. Very early on, we saw some of these cruise ships where hundreds of people got infected, even though everybody was supposedly in their own chambers or isolated in their own rooms. But they were meeting. There were certain common meeting points, meeting for meals and things like that. We've seen this happening in choirs. We've seen it happening in pubs and restaurants, and also in places like factories and dormitories where people are staying close together. So we often talk of the 3 C's, the crowded places, the close contact, and the closed environments where you don't have good ventilation and where you are with a number of other people, one of whom may be infected. This is the kind of setting where the infection tends to spread. There's also been a lot of fear about aerosol transmission. Is this virus like measles or tuberculosis? Is it flying around in the air? Can you get infected? This could happen in certain situations, what is called opportunistic aerosolization. In general, as I said, the commonest mode is person to person. You're within a few feet of the other individual, within 3 feet. You're talking, you have prolonged contact, or you're together working. That's when the infections tend to happen. But very rarely, you could have situations where in a closed environment, poor ventilation, the virus could actually be in the environment circulating for a couple of hours before it settles to the ground. And that way others could be breathing it in. And that's how you've had outbreaks in some of these call centers and things like that. So this is important because understanding how, when, and where the virus spreads is obviously going to inform the effective public health action. And we know today that governments are struggling with containing this infection, particularly in countries and cities which are overcrowded, which have high population density, which have low resources, urban slums, poor access to healthcare, and so on. And they're also struggling with things like schools and colleges, how do you continue education in an environment where you know that this can spread, if you give it a chance. And young children, luckily in this outbreak, the virus has not, it can infect young children, but they don't get sick. It can, 10 to 19-year-olds, on the other hand, are more likely to spread it than children under 9 years of age. There was a little bit of disturbance. So understanding, the biological factors of the host and the virus is very important. Also the immunology. That's the other big area that people are working on now, and that is, what is the immunity to this virus? We know for the common cold, for example, that we don't have long-lasting immunity. You can get repeatedly colds with the same or similar coronaviruses. With the SARS and the MERS, we know immunity lasts for a couple of years. For this virus, we still don't know, because we've only had it for 6 months. And so unless we do those studies over a longer period of time, we won't know. But already there are reports, and again, the media has been reporting on how antibodies are disappearing very quickly. Does this mean that we will not have immunity to this virus? And that's causing a lot of panic among people. But the fact of the matter is that we have not understood fully immunity, because you have different kinds of immune cells in the body. Some of them are more long lasting. So even when antibodies reduce, you could still have those memory immune cells, which can actually get activated and produce a good immune response later on. And also the vaccine trials that are going on now will give us much more information about immunity, and also try and understand why some people have no symptoms at all. They test positive, but nothing happens, and others suffer such severe illness, severe morbidity, and end up in the hospital and intensive care unit. And then even after they get discharged, now there are descriptions coming of long-term neurological effects, long-term mental health issues, fatigue, long-term respiratory issues. People who've suffered have said they haven't felt back to normal even 3 months afterwards. They still have shortness of breath when they walk, long-term cardiovascular effects. So this is not a virus that only affects the respiratory system, it affects many organs. And those are things that we're still understanding. And what has changed very much for the positive is the fact that we understand how to treat this disease much better. A number of clinical trials actually were started. We run a registry of clinical trials where we get the registries from all the other countries, which are consolidated at the WHO. Something like more than 4,000 clinical trials that have been registered already for this virus, which has only been around 6 months. A lot of them initially, of course, were from China, both allopathic drugs and traditional medicines, using what we call repurposed drugs, where you have existing drugs used for other indications, like it could be for influenza or for some other virus like HIV, and then doctors test it in the lab. If it shows some signs of working against this virus, then you quickly put it into clinical trials and you can test it in humans. And this is quick because the drug already exists, it's safe, it's been licensed for use. It's a question of repurposing it. So the first set of trials were all repurposed drugs, including hydroxychloroquine, which is one of the things that has become so politicized unnecessarily. But many other drugs were tested. Many of them were not found to be very effective. And then doctors started describing the other changes, the blood clotting system, for example, and then something called the cytokine storm, which is the immune system overreacting and causing damage. And so it was recognized that you need to calm the immune system. So you actually need to give anti-inflammatory drugs like steroids, the dexamethasone. And at that time, WHO also thought of something very novel, and that was a solidarity trial. And we said, why don't we launch something that the whole world can participate in, which will help us to generate evidence on some of these drugs. Many of them are being unprovenly propagated, including by politicians. And so we need to make sure that we generate evidence. And the other thing that I mentioned is 4,000 clinical trials, mushrooming of trials, many of them very small, unable to answer the question. So a coordinated research effort is really important in a pandemic, because otherwise you have this fragmented approach, which often is using a lot of resources, but not providing the answers that we want. So we launched the Solidarity series of trials, including some Solidarity epidemiological studies. So that means you have a common protocol. Countries agree to participate. Most countries fund their own studies, and you are generating data into a common pool. So today the Solidarity trial has 25 countries participating. We have over 6,500 patients recruited. So it's one of the largest trials in the world. And we are able to answer one question and go on to the next, what's called an adaptive trial design. This is something we want to now promote for vaccines as well, because again, there are a large number of vaccine candidates in development. Some of them, the big companies, the multinationals, have the resources, the wherewithal, and the expertise to run their own trials. There are many other smaller companies which are developing vaccines, which might not get the same opportunities. And so we want to provide a platform for vaccines also to be tested. And I'm so happy to see so many vaccine candidates being developed in India. There are a large number in China as well. And almost every country now has vaccine development efforts on. India, of course, will play a major role in manufacturing and scaling of the vaccines, quite apart from the R&D that is happening. So that's again a model of global collaboration in order to answer key questions, which will enable faster development of products, whether they're therapeutics or vaccines. But also I want to add to that is the importance of equitable access, which in the past, we've had bad experiences in previous epidemics, including the H1N1 pandemic, where vaccines were cornered by high-income countries. And there was very little left for the low-income countries. And it's only when the pandemic turned out not to be so serious that those countries which had actually stockpiled vaccines then gave up some of their stocks to distribute to the low-income countries. Now, that would be a terrible thing if it happened this time around. And the term vaccine nationalism has been used to describe the fact that many countries are only thinking about their own populations. But the argument that we're making is that this is a virus which is everywhere in the world. And it would be impossible for the world to go back to normal as we know it, and for the economy to recover if only pockets of people are protected while the rest of the world is still where the virus continues to rip through populations and destroy economies. You cannot have a global economy that works like that. And so it's in everybody's self-interest to have a more multilateral or a global approach to vaccine deployment and distribution rather than a more nationalistic approach. But it's a difficult issue because most political leaders would first think about protecting their own people. And it is true that they have a responsibility for their own citizens. But at the same time, in this particular case, it is not enough to protect only your own citizens. It is important to ensure that people around the world have access in an equitable way. So what we are proposing is, if we have a limited supply of vaccines at the beginning of 2021, let's say a few 100 million doses, how do we distribute that? Who should get it first? Is it all the frontline workers, the health workers, the social care workers, the police, the others who are really at high risk of getting infection? Should they not be prioritized before otherwise healthy adult populations start getting it? Because there are two options. One, a few countries vaccinate their entire population. Others are waiting for a long time. And you know that today we have 10% of all infections have occurred in healthcare workers. And we've all seen the stories of the healthcare workers around the world who died tragically. So it would be unfair not to protect them before everyone else, gets a chance at the vaccine. So this is an ongoing dialogue that's happening globally. it's a very difficult discussion. Of course, ethically one would say, and morally, what is the right thing to do, but getting consensus on that is a challenge. Now, we have the ACT Accelerator. So again, we try to address this by bringing together global agencies under the Access to COVID Technologies Accelerator that has pillars of vaccines, therapeutics, and diagnostics. And we also launched something called the COVID Technologies Access Pool, which is to encourage people, whether they are scientists or countries or companies, to pool their technologies, pool their IP in this for the sake of the pandemic, so that people again have access. And this doesn't just mean patents of drugs or of vaccines, but it's really the transference of technology that is important here, whether it's how to make a low-cost ventilator or an oxygen supply equipment or a diagnostic kit. So we have to wait and see. I think this will all play out over the next few months. And we hope that political leaders would all do the right thing. I want to come a little bit to the media and what I have observed. As I mentioned, the infodemic, was coined. This word was coined to describe too much information, including an abundance of false or misleading information. This happened on the 2nd of February, so 3 days after the Director General declared the public health emergency of international concern. He said we are fighting two epidemics. One is the COVID epidemic, the other is the infodemic. In May 2020, COVID was the second most used word in all public English language social media posts, narrowly beaten by the word people. So it was people and then COVID were the two most commonly used words in social media. There are today more than 361 million videos uploaded on YouTube under COVID-19. 19,200 articles have been published in Google Scholar in the first 4 months of the year. 550 million tweets included the term coronavirus or COVID-19 or pandemic. Just in March alone, 550 million tweets. And all of these include the spread and propagation of misinformation, disinformation, and rumors, which ultimately, of course, leads to mistrust in governments and public health response. And it's propagated by fundamentally interconnected way of how information is disseminated and consumed through the web, the mass, and social media, and other information channels. So the governments actually are faced, and WHO was also faced with having to balance the pandemic response and an infodemic response by providing helpful information to the population and at the same time countering the misinformation and rumors. A recent analysis by the Reuters Institute of English language misinformation found that 39% of the misinformation assessed was false claims about the actions or policies of public authorities, including government and international bodies like WHO. And the public is actually now questioning the accuracy and relevance of information from traditional sources. So what do we need to do to manage an infodemic? It's obviously not enough to just address misinformation. We also have to build trust so that the good information or the correct information is picked up and used. Because we've seen that the infodemic is also stoking xenophobia and hate and exclusion. And it can actually be quite a far-reaching threat to health and human rights. So communicating regularly with the public is very important. And that's something we also recognize. The Director General, right from day one, started having these press briefings on a daily basis. And this continued right up to last month, actually, when we moved to weekly twice press conferences. So we also need to build collaboration with journalists and local fact checkers, because journalists are the people on the ground. And they actually, so this media interaction that we have on a daily or a twice weekly basis now is extremely important, because you have journalists logging in from all over the world, asking questions specifically about certain countries and so on, but also about the global response, and often providing some information that we then need to cross-check on. So building these partnerships, we have, for example, a regular session with the Science Journalists Federation of the world, where you have 300-400 science journalists actually logging on and asking us questions. And I've myself done many of these Q&A sessions, both with science journalists, regular journalists, and with Facebook Live, where we're talking to the general public and answering questions. So we have tried our best to be as accessible and responsive as possible, and build also relationships with different groups, like the social media groups. So we have been in touch with all the technology companies that run social media very early on, again, saying how do we counter misinformation. And Twitter and LinkedIn and Instagram and Facebook, all of them actually now have mechanisms to pick up and delete that, or if somebody is asking a query, to direct them to credible sources of information. So I think the combined voices of amplifiers in social media and technology, as well as from the academia and civil society, if you have them all singing from the same song sheet or harmonizing, then obviously it's much easier, but it's that is tough. The specific role of science journalists here has really been to explain the concepts in a simple way, the complicated concepts, to simplify them for the public, because then you help people to understand their own risks and how their action can change outcomes. So it is only through amplification, through media, through journalists, that the messages that the science agencies are putting out can actually be communicated. And every time that you draw a line between science and rumor, you actually push people's behavior towards the healthy choice. So every fact that you check, every right question, every time a dry story is made interesting or a complex story seems simple, is adding to the volume of good information that we need to navigate this pandemic. Of course, we're all at risk also of moving from information overload to information fatigue. And people will already are and will get tired of hearing about COVID-19, and there may be a risk of letting our guard down. And so again, we need to continue to keep up the messaging on the important issues, but also to highlight issues that would not have been brought to the front if it were not for journalists. And I think that's, especially now when everybody's focused only on COVID-19, there is a huge risk that we neglect, or we do not see what is happening actually behind the scenes in terms of other aspects of life, both in health, so other diseases. Like, I'm very concerned about tuberculosis, for example, and the fact that TB case notifications have dropped by more than 50% in many countries actually in the first 6 months of this pandemic, because people have not been able to go to the hospital, healthcare sites have been disrupted, clinics are not open, etc. Labs are already overwhelmed. But also what's happening to nutrition of young children, what's happening to violence against women and domestic abuse, what's happening because so many people have lost their livelihoods. So what's happening in terms of household food and nutrition security, but also the general mood of the people. And then finding solutions, obviously, once you understand the issues and what's going on, then one can think of what needs to be done to tackle it. But that kind of reporting is very important. As I mentioned before, I've been so impressed with the in-depth science journalism that has happened during this pandemic, but also the in-depth journalism focusing on some of these issues, for example, in rural India and in places which are not in the headlights, to bring those stories is extremely important. For that, of course, you need not only energy, but you need commitment. You need to take risks. You need to be out there. And a lot of young journalists in India today are doing that. And again, it's very, very impressive to see all of the online reporting that has been happening. And they're mostly young. And I see quite a large proportion of them also being women. So I think, good information is like a vaccine, actually. And before we have a real vaccine, we have to rely on our known and trusted public health measures. And when people are equipped with the right information, they will do the right thing. I think mask wearing is a good example of behavior change that I can see today has happened, at least in the urban areas. We don't know much yet about the rural areas, but even mask wearing, you can have a wrong way and a right way of wearing the mask. And if you're doing it the wrong way, it's not really going to be of great help. And we know that if over 80–90% of the population is wearing masks all the time when stepping out of the home, you can have a significant impact on the transmission. So this is something that everybody needs to do in order for it to have an impact. And so this is the kind of thing where I think the media plays a hugely important role. So I think those were some of the thoughts that I wanted to share with you. This class that's coming in obviously has 2 exciting years ahead, and then a world which will probably be very different. We don't know what the post-corona world, post-pandemic world is going to look like. We know many things will change for the better, I hope. Our environmental footprints, certainly we need to keep them low. This kind of Zoom meetings, I think, work well in many situations, and one doesn't need to fly halfway across the world in order to deliver a lecture. So those good learnings and good habits, I think we should keep. I also hope there'll be long-term improvements in sanitation, in hygiene, in personal hygiene, as well as public hygiene, and of course, in investments in health, universal health coverage, as well as preparedness for future pandemics and emergencies. And when one prepares for natural, it's not only infectious disease, but also other kinds of health emergencies which can happen and which one needs to be prepared for. That needs investment actually before. It's like repairing the roof. When the rain, when there's a downpour, that's not the right time to repair the roof. The roof has to be repaired before the rain comes, before the monsoon. And so it's we need to really invest in more in preparedness, even though the success of that preparedness is that you're protected from having these kind of pandemics. So it's never visible, and it's always the counterfactual is not easy to prove. So with that, I wish you very successful tenure and very happy tenure in the college.